Now, a quadratic equation has the form or the format. It looks something like this. And how do we solve that? By factoring. We want to find the value that will make it 0. The method, again, we're going to use factoring. I'll give you a lot of examples shortly. I'm going to write the process, the procedure for that. Notice I want this side to be 0, so my first step always for them is move everything to one side. Move everything to one side. That's the first step. Step number 2, factor completely. Step number 3, set each factor equal to 0. Then solve it. And the last step, step 4, check your answers. Make sure they work. And you always want to check them into the original equation. And these are the steps I'm going to use. Move to one side, 9 out of 10 times, everything on one side. Factor completely. Set each factor equal to 0, then solve it, and check your answer. So let me take an example. Or a few examples, and try and solve them. Here is one. X squared minus 4x minus 5 is equal to 0. What is step number 1? Move everything to one side. Is everything on one side? Yes. Step number 1 is done for us. Step number 2, factor completely. Now, if we factor this one, that should be what? X squared is x and x. Negative, 1 is positive, 1 is negative. The 5 is 5 times 1, so you're going to have a negative 5 plus 1. That'll give me the negative 4x that I need. Now notice you're multiplying two things, your answer is 0. How can you multiply two things and get a 0? When is that possible? Yes. If one of them is 0 or both of them 0. So at least one of them have to be 0 for the answer to be 0. So that's why step number 3 says take each one of them, set it equal to 0 and solve it. Now to solve this one, again you need to solve it for 1x. I need to move the plus 1 to this side and change side, change sign. Move the minus 5 to that side, x equals what? Positive 5. So we get two solutions. Now let's check them. Let's see if they work. I'll use my red marker to check. Let me try the x equals negative 1. Let's test it. When x is minus 1, what's minus 1 when you square it? 1. What's the minus 4 times the minus 1? Plus 4. The minus 5, does that equal to 0? Yes, that's good. Let's try the 5. What's 5 squared? 25 minus 4 times 5. 20 minus the 5. Does that equal to 0? Yes. So both answers are good. Yes and yes. Let's try another one. 2x squared equals negative 7x. What's the first step? Move to one side. Let's move them to one side. Bring the negative 7x to this side. Becomes positive 7x. You want that side to be 0. Always. Now we need to factor completely. How do you factor that problem? The first rule in factoring is what? The greatest common factor. Do they have anything in common that you can pull outside both of these terms? They both have an x in them. So if you take an x out, what's left? 2x plus what? 7. Again, I'm multiplying two things, my answer is 0. That means one of them has to be 0. Set each factor equal to 0 and solve it. There's nothing to do to this one, it's already done. It says x equals 0. Now the other one, I gotta move the 7 to that side, and that becomes 2x equals what? Negative 7. And to solve for x, x will be what? Negative 7 over 2. So I found two solutions to that problem. The 0 and the negative 7 over 2. And again, you can test your answer. When x is 0, 2 times 0 is 0, negative 7 times 0 is 0. That's fine. I checked that one, takes 2 seconds. This one's a little bit tricky because it's fraction. So to check this one, when you square that, first you gotta square it. That's what? Negative times a negative, positive 49 over 4. Negative 7 times x, which is negative 7 over 2. Notice you can simplify this. You can divide the top and the bottom by 2. 1 times 49 is 49 divided by 2. That's 49 over 2. The 7 is 7 over 1. Negative 7 times a negative 7 is plus 49. And 2 times 1 is 2. The left equals the right. So both answers are good. Let's try a few more. Let's try this one. 9x squared plus 1 is equal 6x. First step, move to one side, and I like them in descending power. Now to factor this, because that number is different than 1, we're going to use the trial and error method, guessing game. You go, well, 9x squared, you can get that by multiplying 3x times 3x, or 9x times 1x. That's it. That's the only way to get 9x squared, using whole numbers. I don't want to use decimals. Notice this is a plus. That tells me both signs are the same. Both are same as this one. Both are negative. How do you get a plus 1? It's minus 1 times a minus 1. So let's try factoring that. So when you factor that, maybe this might do it. Does that give me negative 6x? Yes. So that is the right factoring. So now we take each factor, set it equal to 0, and solve it. Move the minus 1 there. 3x equals 1, x equals 1/3. Since it's the same answer, when you type it on that computer program, you only write the answer once. You don't put 1/3 comma 1/3. So your solution is only one number. It's just 1/3. Don't write it twice. You write it twice, they'll mark it wrong. It's the same answer. Let's try one more. Then we'll add a little twist to it. Move to one side. It's already on one side. Can we factor? How do you factor this? Take 3x out. What's left? X minus 4. So again, you're multiplying two factors. You're multiplying this factor times that factor. Your answer is 0. Set each of them equals to 0 and solve it. X will have to be what here? 0. X will have to be what? 4. I'm getting lazy. I'm not checking to see if they work. You can look at them. I know they work. I can do it in my head. I know when x is 0, this is 0 minus 0, still 0. When x is 4, 4 squared is 16 times 3, that's 48. 48 minus 48 is 0, so both answers are good. Let's put a twist in it. Now, you're probably wondering, that doesn't look like quadratic equation. That's just a fractional equation. Why is it here? When I have fractions, and I just finished doing that with my early class today, algebra, and my statement to them, I says, if you see fractions there, I know not many people like fractions. There's a quick fix to get rid of all the fractions. And what is that? You need to multiply each term by the LCD. Lowest common denominator. Remember, the 3 is 3 over 1. So you get 3 little baby fractions. What's the LCD for them? The definition of LCD is the multiplications of all the different factors, each of them raised to its highest power. Need to write it down? LCD. The multiplications is the multiplication of all different factors, each of them is raised to its highest power. That's the definition of LCD. A little bit different. That's my definition of LCD. Notice when you look at that, this is one package. You can't separate them. People look at the x. Oh, there's x and there's x. This is one piece. Different than this piece. Different than the one. So my LCD here is going to be the multiplication of all these different factors. It's the 1 times the x plus 2. I don't need the 1, so it's x times x plus 2. So now I'm going to multiply each one of these terms. Only addition, subtraction separates terms. So I get 3 of them. 1, 2, 3. I'm going to multiply each one of them by this one. So let me multiply each one of these terms by the LCD, which is x times x plus 2. So notice I took that problem up here, and I'm multiplying each one of these, each one of them by the LCD. Now let's clean it. Notice this, because this is over 1, we just don't put it over 1. This x cancels that x, top and bottom. What's left there? X plus 2 times 1, which is x plus 2. Nothing really cancels here. We have 3x times x plus 2 equals, this is over 1, and notice again the x plus 2 cancels the x plus 2. What do you have is 2 times x. When you multiply by the LCD, when you come out of that step, you should not have any fractions. All the fractions are gone. If you still have fractions, that means you did not multiply by the LCD. Now let's solve this one. Clean it. 3x times x, 3x squared. 3x times 2 is plus 4x. And what happens when I bring that 2x to this side? It's going to turn to what?
6x.
How about negative 2x?
That's supposed to be 6x.
Oh, 3 times 2. Thank you. Yep. 3 times 2 is not 4. It's 6. It's Thursday.
Yeah,
Almost Thursday. Where is it? Thursday.
Yep.
Problem is I don't drink.
It's good having Fridays off.
I'm going to see the Red Sox tonight. I went online yesterday, bought some tickets.
Oh, yeah.
After the game yesterday, because a lot of home runs. That'd be fun.
Tonight's game?
Yes.
Is that the Twins?
Twins. I got tickets for tonight and tomorrow nights.
Oh.
I'm staying there.
Playing Reds pitchers tonight, right?
Yes.
That's good.
So let's collect like terms. 3x squared. 6x minus 2x is what?
4x.
4x plus x. 5x. Anything else? There's the plus 2, doesn't it? So I took this piece, and this piece, and I put them together. They all like terms. So we're still on step number 1. All of that, we're still on step number 1. Now we got to factor that. 3x squared, 3x and x. The 2 is 2 and 1. Both signs are the same, both are positive. So factor completely we did. Step number 2 is done. So this is step number 1, move to one side. This is step number 2, factor completely. What's step number 3? Set each factor equal to 0 and solve it. Take the 1 there, becomes x equals what? Negative 1. Take the 2 there, you'll have 3x equals what? Negative 2x equals negative 2/3. There are the 2 answers. And step number 4, check your answer. I'm lazy. I really don't want to check them. But what I want to do at least, the least I should do, is make sure that any of these answers I came up with, so the 2 answers here, make sure they do not make the denominator 0 here or here. Because if they make this one 0, if they make that one 0, we cannot use them because you can't divide by 0. So if I let x be minus 1, this will be a 1, it's not a 0. This will be a minus 1, it's not a 0. I'm okay. If I let x equals negative 2/3, this is not a 0. This is not a 0. So there's a 99.99999 chance both gonna work. So when you have fractions, best thing to do is get rid of the fractions first. How? Multiply by the LCD. Okay, let's take an example. Let's say you decided you're going to ride your bike this week for, I don't know, the Jimmy Fund. They have these bike rides in Boston. They go 60 miles, 100 miles, 200 miles. So this race here, to raise money for the Jimmy Fund, we're going to leave Boston and let's go about 60 miles. Where are we going to go? Is the Cape more than 60 miles from Boston? I think it is. They're going to go to Springfield. Not just a little bit over 60. We'll say Springfield. So there's you on your bike. That's the bike, and that's you on it, holding the bike. And you're going to go 60 miles this way, get to Springfield, then you're going to travel back 60 miles in the opposite direction. So we got on the bike, we rode the bike 60 miles to Springfield, then get to Springfield, grab the sandwich, collected some checks, and rode the bike back to Boston. Another 60 miles. It's a little bit windy on the way from Boston to Springfield. You had a headwind slowing you down. So let's say your speed was 5 miles per hour going from Boston to Springfield, less than the reverse. So if your speed here, let me just make a table here. That will make, actually for these problems, the table is really a good idea. So the top half, when you were going in that direction, your distance traveled, how far? 60 miles. And the bottom half, when you came back, what was your distance? 60 miles. We said we have the wind pushing this way, coming this way, slowing you down at 5 miles per hour. So let's do the rate here. if you call your rate, what do you want to call it going from Boston? How fast were you going from Boston to Springfield? We're not sure. Let's call it R. You have a 5 mile per hour wind facing you. So if your speed was R, on the way back your speed should be what? R plus 5. You're going to be going faster because the wind is going to be behind you, pushing back on you instead of facing you. And time. Let's say it took you 7 hours to complete the round trip. Seven hours. That means, if you remember, there's one equation about distance, rate, and time. What is that equation? Anyone? There's one equation that ties distance to rate to time. Distance equals what? Rate times time. Or you can rewrite that time equals distance over rate. So my time here, going from Boston to Springfield, is the distance I traveled, which is what? 60 divided by my rate, which is R. And what's the time for the way back is going to be? The distance, which is what? 60 divided by R plus 5. I'm trying to find how fast was I going on my bike there. That's what I'm trying to find out. How fast was I moving, the rate? Now let's think about this. If I take the time that took me to go from Boston to Springfield in that direction, add to it the time that took me to go back from Springfield to Boston, combine, it should equal to what? 7 hours. It says 7 hours to complete the round trip. $120 miles in 7 hours, that's not bad. We're cruising. Now let's see, the time it took me to go from Boston to Springfield is 60 over R. It's right here. 60 divided by R. Plus the time it took me to come back, 60 over what? R plus 5. If you add them, that should equal to 7. And there's my equation, and I want to solve it. What is my LCD? So given that equation, what's my LCD?
R plus 5.
Yes, R times R plus 5. Notice I'm multiplying each one by R times R plus 5. As I said before, when you multiply by the LCD, when we come out of that step, no more fractions. So I'm going to have $60 times R plus 5 plus the second one. R plus 5 is going to cancel R plus 5. That'll be what? 60R is going to equal to what? 7R squared plus what? 35R. Let's move everything to one side and clean them. Now, I made this problem without thinking, so hopefully my answers will be good. I had a number in mind. I was trying to do it somewhere around 20 miles per hour. Let's see if I succeeded there or not. I had that answer in my head. Try to build the question, the story around it. 60 times r is what? 60r plus 60 times 5, 300 plus 60r equals 7r squared plus 35r. 60 and 60, 120. Move the 120 to that side. Becomes a negative. So 0 equals 7r squared minus, what's 35 minus 120? Minus 155r minus 300. I have the 0 on the left side. It really doesn't matter which side I put the 0, left or right. I forgot I put them on the left side. And now I got to factor this. Seven R. You know, when you make a problem without thinking about it, sometimes it doesn't work out. I don't know if this is going to work out or not. I got my quadratic equation. I moved it to one side. Now, can I factor this? 30 times 10, is that 300? So 30 times 10 will now work. 20 times 15. One's plus, see, one's plus, one is minus. That will not work. It won't give me that number. In my head, I was trying to get the 20 to work out. If that number was actually a plus here, I would have had the 20 and the 15. That would work out beautifully. 75 times 4, is it? Is that 375 times 4? Yep. 75 times 7, 520 too high. How about 25? 300 divided by 25. 25 times 12. Close. None of these numbers are working out. Times 20, 30 times Or 20 times 7. 20 times 7 is what? 140? No, that doesn't work out. 20 times, what, 30? I don't think I can factor to get that number I wanted to get. I had a number in my mind that felt like I don't think I can factor this problem, to be honest with you. And there are actual limitations to this method. I'll change just a hair in it. I'll make a different one. Maybe that'll work out. Because I had a 20 in my mind and 25. Curious there. 60 divided by 20 when I made the problem. That's 3 hours to go there. And this one, 60 divided by 25. Oh, it's not 7 hours. 6.4 hours. I had a number. I used a number in my head. Try to get it to work. So if I use 5.4 actually instead of 7 hours, 5.4 hours, that 20 would have worked. 20 this way and 25 this way. I don't know what was I thinking about. Because this will take actually, because I'm going here faster, my time is going to be less. It will never be 7. 30, that'll give me 20. How about if I go slower? 15. That gives me 4 hours. Yeah, 15. Let's see. $300 divided by 15. What is that? 20? Oh, you know what? That number is wrong. That's why. What's 120 minus 35? 85? I subtracted wrong, right? I knew I had a number in my mind. Because that's 35. Take the 120, that's negative. That should have been negative 85. I knew I had a number in my mind when I was making the problem. I wanted to work out. So I picked an answer. I didn't tell you what that number, and I worked around that number. So let's see if that's correct. This will give me 7r times negative 15. What's 7 times negative 15? It's negative 105. Add to it the 20 there. It is the negative 85. That is the correct factoring. So now factor completely. We did that. Set each factor equal to 0 and solve it. I've been in this room since 8 and it's what now? 11:44, so I'm getting tired. I started to see dots there. So R equals 15. Here 7R equals what? Negative 20. R equals negative 20 over 7. How can your speed be a negative number? Can't be. So physically this does not make any sense. How fast are you moving? Officer, I wasn't speeding. I was only going negative 85 miles per hour. You know, I had the car in reverse. Maybe that's negative. No. So your speed is always positive. I mean, the rate is always a positive number.
I think the negative 20 will look like the clock is behind you.
Well, you can look at, if that makes sense to you, negative 20, go ahead. I'm tired now, nothing makes sense to me. This is the positive number. So my speed actually is 15 miles per hour. I knew that when I made the problem, because in my head I'm going 60 divided by 15 is what? 4 hours here. And 60 divided by 20, that's 3 hours. What's 4 plus 3? 7 hours. I had a number in my mind. I wasn't sure it was 15 or 20 when I made the problem. I forgot. So my speed actually going from Boston to Springfield was 15 miles per hour. On the way back with the wind pushing me, I was going 20 miles per hour. Or after I get to Springfield, I realized I don't want to be in Springfield. People are shooting at me, so I just jumped on the bike and I took off. Now I'm cruising at 20 miles per hour. So that's an example where some of these problems you might see. Try to give you some real life problem. Okay, that's this section.